Okay, so we're going to learn some new identities now today. And these are a little bit different than what we learned before, because the ones we learned before were all related like cosines and tangents and things like that. This has to do with the cosine of two different angles. And so what we are supposed to do is we are supposed to figure out, does the sine of u plus v equal the sine of u plus the sine of v? Okay? So can we like distribute the sine? Is that going to be a true thing or not? And guess what the answer is?
Yes.
No.
Well, let's find out, shall we? Pick a value for u. 5.
How about we slow it down so I can get this down?
Okay. Pick a value for v.
1.
1. Okay. So we want to figure out, is the sine of 5 plus 1 the same as the sine of 5 plus the sine of 1? Are we radians or degrees? Radians? You want to go radians? All right, let's check it out.
Question, do those batteries come in?
What?
The batteries, they come in?
Yeah, a long time ago.
Really? Can I get some? My calculator's dead.
Yeah. Okay, so I'm going to make sure that is it yours or mine? Okay. I'm going to make sure I'm in radians. Okay, so I want to go sine of, you guys randomly chose 5 plus 1. And if I do that, I get that. And I want to compare that to the sine of 5 plus the sine of 1. Can I get a drum roll? Can I get a drum roll?
Can I say?
It's not the same. Okay? Say that one more time. Oh, right. Yeah. So this is the sine of 6.
Yeah.
Right, exactly. And this is the sine of whatever 5 is plus, yeah. So these are two different triangles, and this is a totally different one, okay? So unfortunately, that's not how that goes. So that's a big fat no. It doesn't work that way, okay? So, and the same thing, not surprisingly, is true with cosine. And so what we get then is cosine some or different identity. Okay, so if you are going to take the cosine of an angle plus another angle, or the cosine of an angle minus another angle, then that equals the cosine of the first angle times the cosine of the second, minus or plus the sine of the first angle times the sine of the second. Okay? So if you're adding them, if you're adding these angles, then that means you subtract these.
Is that why it's those
Okay?
subtractions?
Yeah, that's why it's flipped over. Okay? And if you're subtracting these, then you're adding those. Okay? Does that make sense, kinda? So when you add, then you end up subtracting, and when you subtract, you end up adding. Why did I just do cosine? We were just messing with sine. Let's find the sine one. Sine one is the sine of some two things added together or subtracted. Good morning. How are you? Can you talk to Tucker? If Tucker was here, you could talk to him, but he's not. Okay, bye. Sine then is a little bit different. If you want to find the sine of two things added together, it's the sine of the first angle times the cosine of the second, plus the cosine of the first angle times the sine of the second. Right, so for the sine one, when you add, and when you subtract, you subtract. For the cosine, when you add, you subtract, and when you subtract, you add. Okay? Not confusing at all, right? A little bit. All right, so let's check and make sure that's true with the sixth thing. What?
Can we go back, please? So sine, you add,
No,
and
there's
add,
something
and you
else.
subtract, and subtract.
Yeah, the addition signs are both on top and the subtractions are both on top. Okay, so let's see if this works with the numbers that you said. You said the sine of 5 plus 1. And we got that. So if I use that little formula, then to get the same answer, I have to go the sine of the first one times the cosine of the second one plus, what's the next thing? Cosine of the first one times the sine of the second one. And if I do that, then I get the same answer. Okay? So the book goes into how those are derived, but I'm assuming you don't care.
Why would you do all that work?
If you do what? Excellent question. Why would you do all that work if you could just do it with the first thing, okay? Well, let's say you wanted to find the exact value
Should we write this down?
of the cosine of 15 degrees. Okay? Now, as soon as you see that word exact, that means we're not using a calculator, because as soon as you bust out the calculator, you're going to get a big long decimal number and you're going to end up rounding. Okay? So exact value means, you know, square root of 3 over 2 or something funky like that. Okay? Do you know the triangle that is a 15, 75, 90? No, me either. Okay, what are the ones we know? We know 45, 45, 90, and we know a 30, 60, 90. So these are the angles that we can choose from. Is there a way that you can combine those by either adding or subtracting to get a 15-degree angle? 45 minus 30. So instead of finding the cosine of 15, we're going to find the cosine of 45 minus 30. Okay? So what is the subtracting cosine formula? We're not in any mode because we're not using our calculator. What? Okay, so this is going to be the cosine of 45 times the cosine of 30 plus, right? Plus, because in the cosine formula, if you're adding, then you subtract.
That's why you do it.
Yeah, and if you're subtracting, you add. And since in this case we're subtracting, we're going to add. So it's going to be plus the sine of 45 times the sine of 30. Okay? Does that make sense? No, you shouldn't. Why would you? Why would you ever like anything we do in this class? I'm just saying. Just throw that out there. And you have no answer, no response. All right, so that means you have to find the cosine of 45, the cosine of 30, the sine of 45, and the sine of 30, and you need to do it like with exact values, right? So you need to go to the 30, 60, 90 triangle and 45, 45. So whose eyes get big because that's a lot of triangles, that's a lot of thinking. Well, I think it's time for us to cut to the chase and for me to give you the, I will, world famous circle chart, which hopefully I have saved somewhere. Hot enough in here for you?
Yeah,
Let's see, what do you think? Trig identities? Nope. How about random stuff? Anybody see a circle? What I'm going to give you in a second here is a chart that we can use so we can stop doing all that work with figuring out all the stupid things, okay? So you can just look this up because we know how to do it now. So if you want to figure out the cosine of 45, the only bad thing about this chart is that it's in radians. but there's a little translation on the circle right here. So 45 degrees is pi over 4. So what is the cosine of pi over 4? 1 over root 2. Pi over 4 cosine 1 over root 2. So I can replace this with a 1 over root 2. Cosine of 30. How many radians is 30 degrees? Pi over 6. If I want to go cosine of pi over 6, that's root 3 over 2. Plus sine of 45, so go to the chart again. 45 degrees is pi over 4, so the sine of pi over 4 is 1 over root 2 times the sine of 30. 30 degrees, you remember, I'm sure, is pi over 6, so that is 1/2. All right? So then if you multiply those out, you get root 3 over 2 root 2 plus 1 over 2 root 2, or root 3 plus 1 over 2 root 2. Okay? That's more fun than a kick in the face. Not much, but a little bit. Like if I asked you when you walked in this morning, okay, would you rather do the math assignment or would you rather get kicked in the face? You might think about it for a little while.
I think definitely.
Yeah, you might kind of look at what kind of shoes I'm wearing. You might think, well, Mr. Roberts is a pretty nice guy. He probably won't kick very hard. Pretty close. Close call. Okay? You choose to kick in the face?
Yeah, we'll not do.
Just for one day, though.
All right.
Okay, so now that you all have that chart,
Just tell me what they go gas is. I mean,
what?
I'm taking a fantastic one.
Where's the weed?
Korean,
No.
Japanese.
Are you?
Do you get it? You want to try a few on your own?
I feel like 5.
Let's give you a short assignment.
Super short.
Short assignment.
I already said what? Yeah. Yeah, you said
And can I have some batteries too for the other stuff?
Sure. Her name's
And I would never kick anyone in the face, just